Hi, I'm doing Paul McWhorter's Pico W lessons, and I'm up to lessons number 83 and 84. Now lesson number 83 is all to do with debouncing a button, and I'm using my FreeNove projects board for a Raspberry Pi, and I'm managing to connect my Pico via the Pico to Pi hat there. I've made a video about this and I'll leave a link below. It's quite useful in this case because I'm not using any other, I'm not having to use any of the exposed pins because there aren't any. So there's the LED and there's a button, and that's all I need. Right, a quick look at my code. I've made a flag class just to hold the variables that I'll be using to avoid global variables, set up the button and the LED, and I'm using a timer and an interrupt. So when we go down to the main bit of the program, I'll come back to that bit. I'm calling the function set callback. Now that's normally called by the timer, so it expects to have, if you look at it there, it expects to have something in there. So I've just put none, and it doesn't mind at all. And all that does is it sets up the interrupt on the pin, and as opposed to on the Arduino you can have change. The equivalent to change is falling or rising. And so that's all I'm doing. And then in the while true loop, as opposed to pass, you can have 3 dots, which I think is quite good. It's easier to notice that you haven't put your code in, because pass is the same colour as all the other keywords, so I think that's quite good. I think that's called an ellipsis. Right, so what we do is I've set the interrupt on the pin there, and when something's happened it goes into changed. Immediately I'm setting the handler on the interrupt to nothing, which means I'll be able to ignore all the glitchy up and downs, and storing the value as the state of the button and just saying, hello, has the button been released? If so, add 1 to the count and toggle the LED. And when printing out the count, I thought, I wonder if you can put emoticons in there. So what I did was I went into WordPad, and then I pressed the Windows button and full stop, and then I copied it in. I copied it from WordPad into here, and it works. So I thought that's great. You can have pretty little pictures, and then whether or not it was released or pressed, I'm setting up a one-shot timer with a very short period, and all that does is it resets the handler to changed as opposed to being none, and that all seems to work perfectly well. So we will run this jolly old program, and right, it's on, it's off, it's on, it's off. Now take my word for it, it works. I am not going through 50 presses. So I will pause the video and come back with lesson number 84. Now for lesson number 84, I'm using a different board because it's got 4 LEDs built in and built-in buttons, so it makes everything an awful lot easier. And this is creating a binary counter again using LEDs, and so I've just expanded on my code really. So I've got 2 buttons, an add to the counter and a subtract the counter. So I've just doubled up on those. I've doubled up on the buttons. I've got an array of pins, and then I just make an array of LEDs. and then that overflow number is the maximum number. So if you've got 4 LEDs, you can count, go away, you can count up to 15. So that overflow number is 16. And if I was only using 3 LEDs, it would be 8, etc., etc., etc. And I'll be using that later. So as before, I'm just, I've got the callback, and I'm setting up the interrupt, and the callback from the other timer setting from the interrupt. I've just duplicated the code because I thought it might get, if I tried to use the same interrupt, everything would get very, very messed up. So I've just got, as before, that's the handler for the add, and it's the same, only I'm just saying if the flag count is greater than 15, as in if it's 16, I'll make it 0, which means it will work nicely on the binary counter, and then I call binary counter with that. And in the subtract one, if the count has gone down to below 0, I just set it to overflow num -1, which is 15. So that all works wonderfully, and nothing else really apart from the binary counter. Now I think this is quite an interesting way to do it. I thought if you want to use LEDs as a binary counter, that is just like having a binary string. So if we go into shell, view shell, I will show you what I mean. Come on. If you just do that, so that's counting from 0 to 15, and then you're just printing the binary string of that number. There, as you can see, 0, 1, 2, 3, 4, blah, 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 blah. The only problem is it doesn't have leading zeros. And if you're wanting to use it to control your LEDs, you want leading zeros. So then I came up with this. In fact, I did this way back in lesson number 3 for this. So here we have, you're counting from 0 to 15 again, and then you're printing the binary string of that, but you're adding 16 to it. Now that means that you aren't losing any of the leading zeros. I will show you. There. So your binary string, you have 0B to say it's a binary string, and then there's the 1, which is the 16, and then you've got 1, 2, 3, 4 digits, doink, 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 which is exactly what you want for your to control the LEDs. Cunning, huh? Then I will just show you this. Now again, we're going from 0 to 15, and we're printing the binary thing, but I'm missing out the first 3 digits, which is the 0B for binary, the 1, which is 16, and I'm just printing it out. And there we have all of the states for the LEDs. Now in my program I'm actually doing something else to it, because I've got a I'm looping through 4 times on the LEDs. So I'm setting the LED, sorry, there's a cat about to jump on me. So I'm looping through, so for each LED I'm setting the value, and that is, there's the binary string as like that, only I'm taking J plus 3, that digit. So in fact what I'm doing is that J plus 3 is saying you miss out the first 3, 1, 2, 3, and then you miss out J. So well, anyway, it works out. So it means that for the first LED you're getting that, second LED that, third LED that, and going from the left. So that is how I did that. So we'll run this jolly old program, and if a cat appears on the screen, you'll know why. So we'll run this, and there's the up button, there's the down button. So there it goes. Count, and you can see 1, 2, 3, 4, 5. Then you can go back again. Whoops, that is a dodgy button. That's not my program, it is the button. Right, 0, down to 15, up again, there. Wonderful. Apart from the dodgy button, which is not the program, it is the button itself. It works